Hello and welcome to this session on quadrilaterals with Mathomat. In session 2, part 4, we will look at a fourth way in which to prove a quadrilateral to be a square. Let's move on to our fourth proof. Theorem 4. How to prove that a quadrilateral is a square. In Theorem 4, we need to prove that the quadrilateral is, first of all, a rhombus and that it has one right angle. To prove a square to be a rhombus, we need to prove that it has 4 congruent sides. This is not the only proof. We will discuss rhombi in a later session. I am going to demonstrate this with the template for you. We'll be drawing a square and I will rotate the template. I am going to use shape number 23 on the template. I want for you to pay attention to the fact that I will use only one side of the square. I picked the left-hand side closest to the millimeter ruler. Have you got your template? Get some paper and a pen and follow along. I'm going to draw my square in pencil. I'll be using a different color to draw in the rest of the sides. I'm rotating my template and I'm using the left-hand side to draw the bottom side of the square. I'm rotating my template around my mechanical pencil. It helps to keep it intact. And you can see I'm using the same side to draw all 4 sides of this square. We've proven all 4 of the sides to be congruent. Let's have a look at something else that we're going to use today. If I draw an angle, I've drawn my square's vertex, and I produce the sides. I'm making the sides longer in length. That did not have any effect on the magnitude of my original angle. Keep that in mind. We have just proven that this quadrilateral has 4 congruent sides. This means the square is a rhombus. How are we going to prove one angle to be a right angle? We will be using a different part of geometry. An angle on the circumference of a circle that is subtended by the diameter is a right angle. Let's draw a diameter. If we draw a triangle so that one of the sides is on the diameter, then the angle on the circumference must be 90 degrees. This triangle is inscribed in the circle. There are more ways to prove this 90-degree angle in Euclidean geometry. We'll be using the square, the rectangle, shape number 3, the circle, and also the scalene right-angled triangle. Are you ready to follow along? I'm drawing my circle and I'm going to position my circle center finder over it so that I can get the midpoint of the circle. This will allow for me to draw in a diameter. I'm going to use the right-angled scalene triangle on the template. And I'm going to draw it so that one of the sides are on the diameter. We know that is a right-angled triangle. That means my rectangle must fit. We can also measure the angle. It will be 90 degrees. How will we do this with our template? We'll start again with our circle. This time I'm going to draw in 2 diameters. The reason for this so that we can position the square. I'm placing my square so that the second diameter I drew acts as a diagonal. I'm going to move my template up so that the angle of the square is on the circumference. I'm drawing this angle in green, but you can see it's not reaching the diameter, so we will be producing the sides. This way, if I draw in my third side on the diameter, I'm going to have a triangle. Let's measure the angle. The rectangle fits. The protractor measures a 90-degree angle. And of course, the vertex of my square also fits. We've just proven one of the angles of that quadrilateral is 90 degrees. So we have proven 4 sides congruent, and we've proven one angle to be 90 degrees. We've used a diameter. We've positioned our square. We moved it up so that the angle touches the circumference. We've produced 2 of the sides, and the diameter acts as the third side of that triangle. We know we have a 90-degree angle on the circumference. Thank you for watching part 4 of Quadrilaterals with Mathemat. Please join me in part 5 for our next theorem. See you then!